This will be day 18 of me learning TypeScript. Today we're going to do generics. And while I was watching yesterday's video on day 12, I realized that instead of saying day 12, I say day 11. So the dates are starting to confuse me. So it's normal. Okay, it is normal. Okay, this will be day 13. I'm gonna do generics, which means the days of doing projects are finally approaching. So this is that. Okay, I'm just gonna get into it without wasting any of your time. So generics are one of TypeScript's most powerful features. They allow you to create reusable logic that works with many types rather than a single one. Think of data structures like a queue or a stack. They hold any type of data, so it will be really annoying to re-implement them for every type, number, string, queue, user, whatever, etc. type you have. Generics let us create a single type, a single queue with just this syntax type that work with any type T. The best part of that, when we use that queue with a specific type, TypeScript won't lose that type information. Generics are a way to reuse behavior across types without resorting to any, which we know that any is bad, and you would rather be advised to use the unknown, which will need a type. Any just allows you to do whatever you want. Okay, you may have already noticed, but TypeScript utility types are all generics. Okay, for example, the partial is a generic type that takes in a type T and returns a new type with all properties of T set to optional. Partial set to optional, and then there is record, there is omit, there is those types were just I love them. Those utility types, just gonna be using them after this. Okay, so the example generic syntax is an example of a generic type parameter. Example generic is the name of the generic type, promise, basically anything that can operate on the various types. And T is the name of the type parameter. T is just a variable name. We could call it anything, but T is a common conversion. Okay, TUV, I think they are the most common conversions that are used in generic. Creating custom generic functions. So we're building some client-side front end. I know, okay. And we make tons of fetch to backend server. We might have a lot of code that looks like this. Okay, so an asynchronous function, fetch from API that takes in a URL, then tries this and catches an error. So it awaits for the fetch from that URL. This is the response. If the response is okay, then it's not okay, we throw an error, or we return await the response to Jane or so on. So why are we doing await again? Await. Okay. Whatever. Okay, it's an error. The error will be caught and then the console logged, and then undefined will be returned. So we could lazily leave this as is, but then it will always return a promise any, which has no useful type information. Instead, let's make it generic. So asynchronous fetch API, yes, like where we're passing the type of the type T that we're going to be using in this function. So it will return a promise of type T or undefined in case of an error, I guess. Yeah, here it will return a promise of type whatever the type is. Okay, now whenever we call it, we just specify the type we expect to get back. So comments await. That's a lot of await. Okay, fetch API, then our type will be passed here. It's an array. It's an array of strings, I guess. It's an array of it's a type of array of objects, I guess. Yeah, it's usually just array of objects. So this will be just an object, I guess. Should be returned. This will be an array of posts. This will be just an object, a user. Okay, like I say, a single user, multiple comments, multiple posts. Okay, assignment test support here we store. Okay, I support here we store all support requests in a queue. We also store emails, numbers, and payments in queue. It's a legacy thing. Okay, complete the get first utility function. It should be a generic function that returns return the first item in a list or undefined. So yeah, so we just use if statement, if then else return undefined, because our thing was empty. Okay, we just first to check if the array is empty. If the array is empty, return undefined, and then do whatever we're doing if it's not empty, because we're just taking one thing. If it's not empty, this one thing. Okay, multiple type parameters are there's no need to be limited to a single type parameter in TypeScript. They're just parameters. Okay, and you can have as many as you need, but please don't go crazy. FYI, don't go crazy. Okay, remove that is just a random name. We're going to use number names in this lesson. Let's be aware of short capital letters like TUV, etc. are the most common conversions for generic type parameters. Let's create a function that transforms its inputs. It takes transforms its inputs. It takes in an array of items of type. Input type, a function that takes an item of type this and returns an item of type. Output type, and it returns a new array of items of type output type. Okay, so the function will be returning this type, an array of output type. It takes in one item of input type and an array and a method, a function that takes this item and then returns a type which can be returned, which will be made into arrays that will be returned by the transform function. So this will be the array of type output. So I guess we're just gonna say input of inputs. So this will be array of input types, and then each is passed into the update function, which will be passed when we call the function, and then the outputs are from here, that will be returned from the function, are pushed into our outputs array, and then that output array is returned as that. See how long the function signature gets. That's why TU are the most popular. Okay, let's see. Yeah. This is too long. If you've been paying close attention, we've basically built our own version of array prototype.map. Okay, now we can use our own custom transformers with our custom transform function. Okay, so we can use this transform function now to pass in some types. So if we have an object of type human and create an array of objects of type human, and then this is a method that takes in this is just human, takes in an object of type human and returns a string, which the string is this. Okay, I guess it will be taking in an object from here and returning a string of the name. Okay, we're not using the age, it's redundant, man. Okay, so that is, and then the transform is passed in, that the it's passed in with the array of type human. No, this is an object. What? Yeah, this is like saying that the object is of type human and we're returning a string. Okay, no, this is just saying that the human's array is of type human, and then this method returns a string. Okay, yes, because this is input type and then this is output type. Yeah, the output type of this was string, and then the input, the array, this array is of type human. So those objects will be passed, and then an array of strings will be created and returned as this. Okay, without changing our transform function, we can do it to transform entirely different types of data. So if we have this array, we have the method double, takes in a number, returns a number, that same number multiplied by 2. So we do this, an array will be returned of that number multiplied by 2. So this will be 2, 4, 6, 8, 10. Okay, yeah. So assignment: the Zaporia data engineering team needs to prepare LLM training data by creating arrays of loosely structured pairs. Complete the pair function, takes in two arrays, one with input of type A, one of output type B, returns a list of training pairs, tuples. Okay, AB, one for each index until the shorter list runs out. For example, if you have 2 arrays, laying under 4 items, and this one is for 5 items too. So we return a tuple for each pair, and we return a list, return tuple, one for each index. For example, okay, so we're returning these tuples, and then they're going to be pushed into an array and return that array, I guess. So what we're going to do is that we're going to have mtype param I should have mtype param.ts, and then we'll have this. So let's create our array of type tuple of, okay, just do an empty array, and I guess we can come here and do I less than a dot length and I less than b dot length, and then we'll do this as that. Okay, let's just save our tuple. Okay, let's just do my tuple to be a tuple of type ab, which will be this, then this, right? Okay. Can't find I. Here it is. What do you mean you can't find I? Yeah, let's just do, and then okay, the for loop for let I equals to 0, I is less than a dot length, and I is less than that. Okay, yeah. Okay, then we have, when editing for, would have preferred to it's just okay, so we'll do our array dot push that tuple, what's it's created, and then we just pass in my tuple, and then return our array, which will just come here and do console log some stuff. The method is called pair, and it takes in two tuples, two arrays, man. So let's find something interesting. Let's just take this one. Okay, let's just pass it there and remove that and that. Okay, that will be our thingy. Running test that. We should get Frodo ring bear from ring bear, and then same with pet with gardener. Okay, it works. Let's move on. Okay, generic constraints. Sometimes you need your generic functions to know something about the types it operates on. The examples we've used so far don't know anything about the types they're using. So assign function fetch from API, just this. Okay. Ted. Okay. They don't know. Okay, there's the same function returning a promise. Okay, in fetch from API two could be anything. Yeah, that's that's generic. That's like that's the whole thing, man. Constraints are just interfaces that allows us to write generics that operate within the constraints of a given interface type. In the example above, the any constraint is the same as the empty interface because it means the type in question can be anything. Yeah, we can use the extends keyword to constrain a type parameter to have certain properties. For example, like I think I've seen something like this on YouTube, and after that the guy talked about inferring, which was like very, very confusing. So if they're gonna touch inferring, yeah, I'm gonna spend time reading. Okay, so we use the extend keywords to constrain the type parameter to have certain properties. For example, we have an interface as cost, which is the cost number. Apply, then t extend as cost, and then takes in an array that discount number. So what this means, if I remember correctly from that video, saying that t is extend as cost. It's like saying is t a child? Can t can the type t be a child of its cost? So it's like saying, okay, let's just write that. I don't remember. Okay, so with an array and then const value of vals or values, and then value dot cost dot equals to multiplied by the discount. So I guess this will be okay. So it's saying t should, like the t will be an object, values will be an object, so it will be an array of objects. So the cost will multiply the cost by the discount and pushing the value, and then returns the array. The apply discount function works in a type safe way on any type that is the cost property. It says something about it should be a child of this. I don't know like what that guy did. I just have to find the video property. And again, because we're still using generic, say the type information will not be lost when the function returns. So choose an array of objects which has cost. So choose cost people. Okay, choose, and this will work, but people won't because it doesn't have cost. I think it says something like, if you do t that extends as cost, t should it should at least satisfy. So you can do even string. It should at least satisfy this type, but can have more. I mean, like that seems to be what is happening here. Okay, that's basically what it's saying for now. I see. Okay, what will be assignment? Marketing wants to send a campaign to everyone with an email address on file. Complete the plug emails functions. It should accept an array of objects of type T, but only if they include an email string properties. Return the new type. They return a new array of just the email addresses. Okay. So in this case, we're just going to have to implement our own interface, and T should extend it, saying it should at least look like this guy, right? Let's do constraints to tiers. Passing, let's do passing that. Let's have an interface. Let's call it as email. And then we'll have an email, and then our T will extend that has email, so at least we'll know that it has an email. So the extend as email, then it's taking an array of that, and this is returning an array of. So we have an array. Okay, let's just have an array which is never used for now. Then we'll do element in array. Then we'll do array dot push rlm dot email. Okay, what? Oh, we need the type. Let's see. Okay, email string. Return a new array of just the email addresses. Yeah, what are we doing wrong? Nah, this is just okay. What is it saying? Duplicate identifier. Okay, yeah. Let's just do email. Yeah, and then do okay, email array, and then it's alum should have email. It's not saying email that. Okay, what's on type string? Okay, let's just see. Oh, off, not in. Okay, it's an array of it's an array, so we do off. Yeah, so we just push it that, and then we return email array. It's off. In, we use it in, I don't know, I don't remember. It's okay to not remember, man. So this will be the longest video. So the input is taken in an array. Let's just have like a strong array. Our method will take in an array of objects. Let's just do console.log. What is it? And then an object as such. And then do, okay, yeah, you just return an array of emails. Okay, we're coding, right?